further statistics. We are still journeying through, alright? So we are now at Latin square design. Latin square design. Beautiful. And you will love it, alright? Let's see. So a Latin square design blocks two sources of what? Variability. Blocking two sources of what? Variability. A block two sources of what? Variability. Please take note of these. Two sources of what? Variability. Alright. Now, it comes in a form of a square. Yes. It comes in a form of a square. For instance, you know 3x3 matrix, 4x4 matrix, and others. You can see that when we are talking of a square matrix, you can say 3x4 is a square matrix. You can say 4x5 is a square matrix. But any matrix in n by n, we can say is a square matrix. 4x4, 3x3, 5x5, they are all what? A square what? Matrix. So, it comes in a form of what? A square. I hope you understand it now. Alright? Trust you. The Latin letters cannot repeat in row or column. Yes, the Latin letters. The letters can be any alphabet, any of the alphabets you know. But here we are going to base on A, B, C. A, B, C, D. So, the Latin letters cannot or do not repeat in row or what? Column. It can be a case that on the same row you are getting the same what? Letters be repeating. No, it can't be that. I will show you an example for you to know what we are talking about. Alright. When the letters when the Latin letters are arranged such that none repeat in either row or column alphabetically, is called standard Latin square. Standard Latin what? Square. So when we do that arrangement, for instance, let's see 4x4 standard Latin square. 4x4 standard Latin square. So we are going to use A, B, C, D to be our treatment. To be our what? Treatment. Beautiful. So now, you do it like this. You draw a table. Alright. So when you draw a square table, you can divide this into 4. Alright. So now, let's continue. So we can have A, B, C, D. So you can see that in the first row, we are not seeing any repeating what? Letter there. For instance, A, B, C, then you see A here again. No. A, B, C, D. Alright. Now, going to the second row, which possible outcome can you get? Oh, sorry. 1, 2, 3, 4. 1, 2, 3. No, we have to add 1 to the row to be equal to the what? The column. Alright. So now you can see that here it has to be the case that there is no repeating in the row and there is no repeating in the column. So when we start A here, the column here, there will be a repetition in the column here. I hope you can see that. Beautiful. So we can start with B here, C, see something. C here, see something. D here, then the last one will come. A. Beautiful. 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 So now you can see that here there is no repetition. Good. So let's bring this here. D come here. A come here. Then the last one, B. Beautiful. There is no repetition, and there is no repetition in the other side too. How we are getting it in the column? There is no repetition there too. Here too we can bring D here, A here, B here, then we bring the C here. Wow. Wow. So now you can see that there is no repetition in the row and there is no repetition in the column. Beautiful. So this standardized Latin square design. That's what we mean by saying that a Latin square is a standardized Latin square. Now, with this same table, we have to contract another table which is depicting this table. What is what? Depicting this table. That means that we don't want it to be the same, but we want it to be similar, but not the same thing. So let's see how we are going to do that. Alright, so now let's see another 4 by 4. Alright, so now we can start with A, B, C, D as what you can see here again. But we have to do that, we have to start with something like, let's say, B, C, D, A. Anyhow you go about it. You can make it B, A, B, C. Just that your row and your column shouldn't repeat itself. That's all. So you can let it be anyhow you like. In fact, you can be asked to come out with about 4 tables or 3 tables. Alright, so let's say B A C B C. But you can see that the first one I clean it can also be possible. Alright. So you bring A here. You bring the B here, you bring the C here, then you bring the last B. The same way, the D here, the C here, the B here, then you bring the last A. Beautiful. Now we can see the pattern. C here, B here, A here, then you bring the last B. Now you can also see that with this table, both the row and the column, there is no repetition. Beautiful. There is no repetition. Alright. So with this, try it on your own. Come out with another table that will depict what we have on the board. Alright, so I'll be back for us to see some questions, then we move on. Love you. Alright, so we have a question on the board. A farmer wishes to test the effects of 4 different fertilizers. And we have fertilizer A, fertilizer B, and fertilizer C. Remember, and lastly fertilizer D. Remember, these 4 fertilizers are the treatments. Good. On the yield of wheat, in order to eliminate sources of error due to variability in the soil fertilizer, he uses the fertilizers in a Latin square experiment. He uses what? The fertilizer in a Latin square experiment arrangement as shown below. Why Latin square experiment? You know that in Latin square experiment, we consider how many sources of variability? 2 sources of what? Variability. Alright, so that is why in such cases, it's only Latin square that will help you to perform such an experiment. Alright. The number indicates yields in bushel for unit area. A. Perform ANOVA to determine significant level of alpha. So now we need to perform an ANOVA table to determine these experiments. Alright? Okay. Then, using a significant level of alpha 0.05 and beta 0.01. So square design, two significant level will be what? Will be given to you. Alright. So now we have B, we have to complete another what? Table. So now, this is the table giving us. This is the experiment. This is all about the experiment. And you know, in fact, the moment you see the table, you have to know that this is a lattice square design. Why is it a lattice square design? One, we are considering two sources of what? Variability. In order to see the effect of four different what? Fertilizers. Now, when we were doing block, we had a table to be like this, right? But on the block, we compare and what? Assign. That is what we do in block. So you see that when we are doing the block, and you are summing up the rows and the column, you need to rearrange what you have there, right? So for instance, if this was to be blocked, you have to rearrange it. Let's say you have your A here, you have your B here, your C and your D. Then you pick up the A's, the B's and the C in the arrangement form like that. But in the lattice square design, we don't do that. We consider it as what you see there. So the first thing to do is to sum up all the rows and all the columns. So you sum it up. So let's add 18 plus 21 plus 25 plus 11. That will give you 75. So this is the total here. Alright. The total. Then the second row will give you 68. Make sure you also test to confirm it. The third row will give you 82. The last one will give you 70. So that's what we have for them. Then you come to this. Then you add this, that. And that one too, you get here to be 77. You get here to be 74. You get here to be 73. Then the last one, 71. Alright. In the same way, when you add what is here and what is here, you have to get the same results. And your results will be 295. 295. So the result on the row and the column is the same thing as 295. If you don't get the same, it means you are wrong. Okay? Alright, then you see this topic, this whole course is dealing with a lot of calculations and all that. So when you're doing something, you have to be careful. Okay. Now, here we are going to consider, you see, I love it. In block, you consider two things, right? That is the treatment and the block. And your treatment is on the row, and your block is on the column. Good. But in the lattice square, you consider three. Beautiful. One is the treatment, and the other two. That is why we are saying that we consider two sources of what? Variabilities. The other two is the row and the column. Is the row and the column. So we are going to consider three things. That means that we have to come out with how many hypotheses? 3. Good, beautiful. I love it. You know, I trust you. You are all these things. All right. So now, yeah, experts. You are all experts. All right. So now, we are going to state 3 hypotheses. One for treatment, one for rows, and one for what? The block. So this is how we are going to do it. Good. Initially, what you have done here, you already have the rows. The rows, because this is the total for the row, so you already have the rows. And you also have the other side too. But we are left with what? The treatment. Now, how we find the treatment in the block is not the same as the Latin. See how we are going to find a treatment in the Latin so that you can link the two and not be confusing yourself. Alright, so here's what we are going to do. It's just simple. Don't forget our two alpha levels. Alright, so watch. So the treatment. Beautiful. So you draw your nice table like this. A, B, because we know that the treatment is what? The A, B, and the what? A, C. But just that in Latin square, you consider two sources of variability. That's why we are considering the row and the what? And the column. So, what you are going to do is that this is the treatment, yes. So when you come here, you will sum all the A's up. Then you write it here. Bam. You sum all the B up. You write it here. Bam. In the same way, the C and the D. So take your calculator. Take your calculator. Me, I have my results already, but you take your calculator and let's do something. Alright? Do you have it? So 18 plus 20. Let's try one. 18 plus 20. 18. So here we have only one 18. Here. Okay. Let's do it step by step. 18. First row. 18. 15. Plus 15. Oh, plus 20. If you don't do it row, you add two things again. So be careful. Then the last row, we have 17. Beautiful. So we have the summation of the A treatment to be 70. 70. I hope you also have the same thing. It's unless you are using a different calculator. A different I. Alright, so now let's add a B. You can see B here, B here, B here, and B here. And that one will give you 48. Don't copy my own, try your own. 85. 90. 95. So when you are done, you total it. And the total is going to give you 295. 295. Alright, so that is how we get a treatment. So here, the row is here, the column is here, and your treatment is here. Then, what is the next thing to do? Let's move on. I'll be back. Alright, let me tell you. You state your hypothesis. So you're going to state 3 hypotheses. One for the treatment, one for the row, and one for the what? For the block. So how will you state it? I'll be back. Alright? Alright. Welcome back. So that's the hypothesis. Hypothesis. So we have that for the treatment, the rows and the column. And you know this is 4x4 thing. So whether the row or the column, they are all the same. The treatment will be 4. So everything is 4, 4, 4. Just that you can use mu here, mu here, mu here. So you can choose anyone you like. Someone can choose mu, lambda, omega, or anything. But what I chose is mu, alpha, and what? Beta. Alright, so that's how it's going to be. And the alternate hypothesis is always the same. At least 2 of the means are not the same, or 2 of the means are what? Different. Alright, so here, don't forget, we are dealing with 3 things, right? So first of all, you go for sum of square what? Total. Because you have to bring something like O here, because the total is not the same as the treatment. So that we can use SSCR for sum of square what? Treatment. So we are going for sum of square total, sum of square of the treatment, sum of square of the dummy, of the row, and we also go for sum of square of the what? Alright, of the block, of the column. So we are going for this one thing. In order to generate the sum of square of the what? Of the L. And don't forget that one, the total will come first, because the total is greater than all. Then we subtract this from this, this subtract from that. So you will have it. Let's continue. So now let's see the formula for sum of square of the total. So the total is when we use the square of the summation of all the rows and the column. That's why you see, oh, let me explain this to you. The K and the R here is the K is for the treatment and the K is for the rows and the R is for the column. And we know that the thing is n by n. And they are using 4 by 4. So they are the same thing. Whether you use KR or whatever, they are all having the same thing. Alright, so now S per Ij means that we are squaring all the rows and the column on the table. Any value you see there, we are squaring them. Then after that, we add all. So first of all, this thing here, you know it already, the grand total. The grand total is, let's say this is the table. So when you sum this, the value that will give you here, that's the grand total. Alright. So now, this one, so you pick each value on the table, then you square it. And this one you get. So that's, please, here we don't divide by anything, don't forget it. Alright, so minus the grand total square. Then since it's 4 by 4, everything is 4. 4, 4, 4. So 4 times 4, get 16. And the value you get. Alright, so now, let's go for the sum of square of the treatment, sum of square of the row, and the sum of square of the column. Alright, so now, here we are. Sum of square of the treatment. So, I hope you remember the small table that we drew here. That is breaking out the treatment A, B, C, D. Then summing up all the A, all the B, all the C, and all the D. Alright, so that is what we call the sum of square, that's what we are using to find out the sum of square of the what? Of the treatment. So first of all, this is the formula though. That is CR representing the what? The treatment. Alright, so now, the treatment, you divide by what? R. You divide by the R. In fact, you know that the R and the K is still 4. They are all 4, so no problem. Alright, so now the summation of the treatment means that you pick a total of A square, a total of B square, a total of this, like that. And that's what it's going to give you. Then you do the substitution, you go your way. Beautiful. Now, people normally still maintain here to be T, but I don't like it like that. This is the sum of square of the row, right? So here should be R, so that you identify it quickly. So it's not about the formula, it's about you getting the right answer. Okay? Alright. So sum of square of the row, it means that when you go to on the table given to you in the question, we have the row and the column. The totals on the row, right? The totals on the row. Pick it, square each of it. That will give you this. Square each of it, and that's what you are going to get. Then that one you divide by what? The R. Now, don't forget that the K representing the what? The row. Alright, and the R representing the what? The column. So that place you divide by what? R. In fact, the R and the K is still the same thing. So when you're doing Latin, don't even care about R or K or whatever. It's still the same division you're going to do. Alright, so after that you do the substitution here, and that's what you're going to get. Sum of square of the column, yes, you see, C to represent here. So this means that you are squaring all the column. You see that total there. Those values here, those values we had down there. You are going to square each of it, and that's what you're going to have. So when you do the substitution, this one will come here, this one will come here, this one will come here. So that this will be 4. You see, whether R or K, it's still 4. So don't even worry about that one. Okay? Here 2 will be 4. 4 times 4, which is 16. Alright. So the grand total, you know the grand total already from here. So we'll go and do the substitution. There was no space, that's why. So that's what you're going to get for that. Alright. Now that we have sum of square of the total, sum of square of the the column. We are now going to find the sum of square of the error. And you know that one already, right? Good. Continue with it. Alright, so now, that's the final form, sum of square of the error. This one is, don't choose, okay? Sum of square of the error, the total will come first, then the rest of the sum of square will come. Simple, okay? That's it. Then you get the sum of square of the error. Now, I don't want you to confuse yourself with the formula, so I'm doing something, I want to let you know. You know the R and the K we are using, they are all 4. They are all 4. So, in coming to find the mean square of the treatment, mean square of the row, mean square of the column, and the mean square of the error, you divide by each degree of what? Freedom, right? So if you don't take that, you'll be confused. Which one is the R, which one is the K, or whatever. Let's get rid of all those things. So, I'm going to let R and K represent T because they are all 4. So that you will not be confused of yourself. I hope it's clear. Alright, it should be clear. So when you find the mean square of the treatment, it will be the mean square of the treatment over T minus 1. Simple. And you go your way. You know it's 4, so 3. Mean square of the row, you know that one to T minus 1. You can only do this in Latin square. So this will give you 4 minus 1, which is 3. Then the mean square of the row will come, then you get it. Alright, beautiful. Mean square of the column. So the sum of square of the column over T minus 1. Yes, it's still T minus 1. Alright, so that one is going to give you this. Beautiful. Here we are. When you get to the mean square of the error, it doesn't mean that we are combining T minus 1, T minus 1, T minus 1. No. This is what we are going to do. We are going to consider T minus 1 and T minus 2. That's what we are going to use for the degree of freedom for the mean square of the error. Simple. But be careful. In some books, they have this there. And that idea is coming from here. It's the same as this. Then they will expand and simplify to get this. But see, chewing this is easier than chewing this. I hope it's clear. T minus 1, T minus 2, you go your way because in fact it will make your way simple. So drop 1 from 4, you get 3. So drop 2 from 4, you get 2, you go your way. Alright? So that's where it's coming from. In case you see it somewhere. Alright, so now where we are. F calculated, right? Now let's see the number of F calculated we are going to get here. You see that we have to find F calculated for the treatment, right? Then F calculated for the row and F calculated for the column. And what again? I bet F calculated for error is not bad. That is why in finding the F calculated, we divide by the mean square of the what? Of the error. So F calculated for treatment will be what? Mean square of the treatment over what? The mean square of the error. F calculated for the row will be what? Mean square of the error over mean square of the mean square of the row over the mean square of the error. And F calculated for the column will be what? The mean square of the column over the mean square of the what? The error. This is just simple, alright? Let's see how we are going to go about it. Alright, so now F calculated for the treatment, now the mean square of the treatment over the mean square of the error, that's what you're going to get. F calculated for the column, the mean square of the column over the mean square of the error, that's what you're going to get. So F calculated for the row, that's it. So you see, stating 3 hypotheses means that you get F calculated to be what? 3. Alright, get that 1, 2. Now, here how many alphas are we given? How many critical F critical were we given? 3, 2, 1. Alright, 2. The alpha and the beta. Good. So this one we are going to do. This one you may do it yourself. If you pick the I means that you compare this to this. So as the I here, that is alpha level of 0.01, 0.5. Please let me explain what is here. You see that Here, the T minus 1 is, in fact, the row, the column, the treatment, they are all 4. So we consider all to be here. So that's why here T minus 1. Then the degree of freedom for the error will come, right? And the same way to the same way. Don't be confused. Let's see something. Alright, so now, you know F calculated for the treatment is 47.81. Then you conclude. If is greater than, if F calculated is greater than F critical, you know that you reject the null hypothesis. Then you say that there is no difference in the mean. And if F calculated is less than your critical level, then you say that what? You fail to reject the null hypothesis and conclude that there is no difference in the mean. So that's what I'm going to do. So the same way, you do the same thing for this. So in all, you are going to get about 6 conclusions for this, because you get 3 here and 3 here, or you get 6. Alright, so before you draw your ANOVA table, so I'll be back with it. Please, you all know how to write your decision and your conclusion. So I may not be doing that for you because of time. Alright, so all that you are doing is that you are comparing this to this. When you are done, compare this to this. Make a conclusion go. So I'll be back with the ANOVA table. Alright, so now that's going to be our ANOVA table for the Larsen square. So all that we have done is about this ANOVA table. After everything and you don't present it on the ANOVA table, please, you haven't done anything. So that's how you're going to do. Sum of square of the treatment, sum of square of the row, sum of square of the column, sum of square of the error. That is that. And here, you know, it's T minus 1, T minus 1, T minus 1, T. That's it. And here it's going to be T minus 1, T minus 2. So that's going to give you that. That's the total. And that's, you know where all these things is coming from. So, see you in the next video. Please, be careful. Know how to link the Larsen square to the block so that you don't confuse yourself. And always advise you knowing that at the Larsen square, you need the treatment, the row, the column, and the error. Alright? And in the block, you need the treatment, the column, and the error. So don't forget that. See you in the next video.